Today's lesson we'll be talking about writing equations and graphing in 3D. So here, this first example is talking about lesson or worksheet 3DE. Some of these we did in class. We may or may not have gotten through all of them, but I wanted to make sure that we kind of talked about it again, so you had it all in one section. Since we weren't able to get through everything. So for example 1, we're talking about writing an example of an equation that satisfies the given conditions. So here, remember these equations can be kind of whatever, like what we want. We just need to be able to get them to fit the conditions that were given, and so we have a lot of variability with how we write these. Okay, so for a surface of revolution, meaning that it like has cross sections of a circle. Okay, and the z-axis is an axis of revolution. So if I have a circle, so you have the axis coming out of it. Okay, so let me do this to the side. So let's say I have a paraboloid, so you have this axis coming out from the middle of it. Okay, and so as I rotate around it, this axis is the one that's parallel with that rotation, or allows you to rotate. So think of like a wheel, and it's attached to your car on an axle. That's like your axis in this case, and the tire is the circle. So as it rotates around, that axle is parallel, or is the axis of revolution. So it's parallel with this surface of rotation. Okay. Now, the thing that's perpendicular to it is what's special. So if you go back to our cylindrical surfaces and you think about, like, let's say we're talking about a parabola, so x squared equals 4y. Okay, so then if I was drawing this picture on the graph, then you'd have that parabola, and so then since z is not there, we would draw all our traces vertical to make it like a parabola that kind of like is a sheet of paper that's going straight up and down, just bent in a parabola shape that's opening towards our y-axis. Okay, so in the same concept here, the z-axis is the one that's different than the other variables, or the z value. Okay, so when we're doing our traces, we want to be able to identify which plane has the circle. Okay, so it's going to be the plane that's actually perpendicular to the axis of revolution. Okay, because here, if you look at this picture again, the circle is kind of creating a right angle with that axis, because if you cut that cross section, you have a circle. Okay, so let's say this was my circle, this is my axis coming out at you. To make that thing, you would have to be perpendicular. So if you turned it on its side, there's your axis, there's my circle, so I'm perpendicular to it. Okay, so the one that's perpendicular to the z-axis would be the xy plane. So xy perpendicular to z-axis. Okay, so then that one's the one that's going to contain a circle. Okay, then it says the other planes have to be hyperbolas. Okay, so now this is going to be some type of shape that I have hyperbolas. Okay, and so I have them connected by circles. So this is kind of like our hyperboloid of one sheet. Okay, also a hyperboloid of two sheets fits the same category. It's just that the XY plane would have an empty set, but you would be creating circles on that plane anyway as you moved away from the middle. Okay, so let's just stick with this one. So then that means that for circles and hyperbolas, my variables all must be squared. To create hyperbolas and a regular circle, I need a radius of 1 at least. Okay. So now to create a hyperbola, and z is the one that's including that, it needs to be minus. And to have a circle between x and y, there must be a plus. Okay. Now, you really could do whatever you want with the denominator, okay, or coefficient for that matter. I like to think about it denominator-wise because of the hyperbolas that we had before. So here, I just need to make sure that the ones that I'm supposed to create circles with have the same value underneath so that they do create a circle. So let's say this was 4 and 4. Okay, now my z could technically be the same number, but because of the opposite sign and how hyperbolas work, it doesn't matter if it's the same or not. The only requirement is for that circle, x squared and y squared must have the same coefficient, basically. Okay, so now I can make it whatever number I want to make it, so I'm going to make it 9. There's one example, okay? So just remember that this is just one possibility. You have multiple possibilities, okay? Next one, surface of revolution. You have x-axis is the axis of revolution, and the traces in the other planes are lines. So for here, the axis or the plane that's perpendicular to the x-axis is going to be the YZ plane. Okay, notice how that plane has the two variables that's not attached to the x-axis, right? Okay, so this one's got to be a circle, okay, or have something to do with the circle. Okay, now if you're going to create lines, okay, remember lines always come in two pairs, or in two pairs, in two different pairs. Okay, so XY plane has two lines, so if you imagine your picture, okay, so let me get different colors here. So if, let's say, for the XY plane, you had ones that go this way, okay, and then for the other plane, you have a XZ, so you're going up this way, and this one's going to be super hard to see. Okay, so what I'm creating is like circles this way. So if I drew this a little bit better visually for your eyes, I'm creating ellipsoid, or sorry, circular cones that are double cones. Okay, now notice how the two lines, they intersect at the origin. Okay, so really for my YZ plane, for this to work, it needs to be a point circle. Okay, because it's going to all meet at a point, but then as it expands out like a rippling effect from water, it starts as a dot, but it ripples out as a circle. So that's kind of what you kind of have to imagine as it moves out. It's going to create circles for each of those cross sections. Okay, so to make a point circle, still need all your stuff with y squared, x squared, and z squared, okay? To make lines, or two lines, and to have a point circle, that means your values are 0, because like your y squared and your z squared must be radius of 0 to make a point, okay? Now also remember that tells you that those both must be positive to create a circle. Now to create the lines, x squared must be negative, so that like if I ignored z squared, then I'd have negative x squared plus y squared. Then I could solve or get rid of the radicals or the squares by adding the x squared over and then square rooting. And that creates my two lines. Same thing with ignoring the y squared. I could add the x squared over and ignore and then square root, and then I get my two lines because of the plus or minus. Okay? So here's one option. If I wanted to add some numbers underneath, remember my y squared and my z squared must have the same number. And remember, these don't have to have perfect squares because I'm not going to graph them. Whoops. So I can make 4, and let's say that's 3. Okay? So that's one possibility. Okay? This is just the first part for the first example. I'm going to do another video for the second example. Okay? See you in a bit.